Please do not forget to put your initials on that form on the side where you are attending. And the conference volunteers will be rolling around and they will be having an attendance form. Please do not forget to mark your attendance on the document. So for the first presentation for this session 2, we are having Juan, where is Mr. Juan Foods, Bachelor of Science degree in Food Science and Technology, MSc in Food Processing with emphasis in Sustainability from Purdue University, and currently he is doing PhD in Food Science at Purdue University. Juan will be talking on phytoremediation of aquaponic wastewater and optimization of microorganism production. So let's welcome Juan for his presentation. And one more a small announcement that we will be having total 20 minutes for each presentation, 15 minutes for the talk, and 5 minutes for Q&A. I would really appreciate if you can track your time, and also I will be helping you with these time slides. Thank you very much. So let's welcome Juan Velasquez for his presentation. Thank you.
Good afternoon, and thanks for attending my presentation. Today, I'm going to talk about my research regarding phytoremediation of aquaponic wastewater and the optimization of microbiology biomass production. So my name is Juan Velasquez. I'm currently a PhD student at the Food Science Department at Purdue University. So let's get started. This is just an overview about today's presentation. We're going to start with some background, then move on to materials and methods, and end the presentation with some results and discussion. Okay, so the traditional methods for wastewater treatment, most of them fail to address of the high nutrient content. So in this project, we aim to use microalgae to remove those remaining nutrients from waste streams. So, but our goal was to reduce the nutrient load on wastewater, but also produce in the process. Our main goal was remaining nutrients from the waste stream, and also we thought of optimizing the cultivation process, not only biomass, but something that can be useful for other applications. This research project is part of an integrated aquaponic food production system in which, as you can see, microalgae plays an important role in converting aquaponic wastewater into valuable biomass. And then we utilize these biomass to produce something valuable, as I just mentioned, like stuff like nutraceuticals, food ingredients, or we can use this biomass for other applications, especially in the food industry. Now let's move on to materials and methods. Here I'm presenting you the actual setup of the experimental unit. So this is nothing but a bunch of bioreactors on a shelving unit. So as you can see, we have 27,000 capacity photoreactors, which we use as experimental units. Each system to infuse carbon dioxide for biomass. This system, as you can see, control all the external environmental factors such as temperature, humidity, and also the tailing. It's important to mention this as we were producing biomass in cycles of 14 days, which means that every 2 weeks we harvested this biomass and we started a new. Now let's take a look at the experimental process. The experimental process was divided into 3 stages. The first stage was the collection of the wastewater and the analysis. As I mentioned, we use wastewater coming from our aquaponics systems. So that wastewater we underwent a 2-step filtration and UV treatment in order to remove large solids, large particles such as solids, and also a UV treatment microbial load. So after that, we analyzed that water and what kind of nutrients we had in this type of wastewater. So we use this treated wastewater as a media to grow microalgae. The second stage study, we focus on 3 important parameters: nitrogen to phosphorus ratio inside the bioreactors. After 14 days of cultivations, we collected the biomass by centrifugation. We separate the solids, which is the microalgae, from the treated wastewater. After that, we analyze that treated wastewater in order to see what would be the efficiency of microalgae in removing those grain nutrients. Biomass quality, focusing on the proximate composition. Proximate composition, we analyze the fat content. So you may wonder, what is high-value biomass? So high-value is something that has protein. Just to mention to you, we use the protein content as the main parameter to determine whether or not the next stage of the experimental process was focused on the assessment of the quality of both biomass and treated water. So this is just an overview of the experimental process. As you can see, from the collection of wastewater to the quality assessment of microalgae biomass and treated water. Okay, now let's move on to and discuss some results. Here I'm presenting you a chart of the biomass accumulation over time. As you can see, since the nutrient content of the wastewater used in this study was low in nitrogen compounds, we thought of supplementing with more nutrients in order to make the microalgae all the nutrients in general. So what I'm showing here is when microalgae is the biomass accumulation is quite low. However, what we did is we stress the cost on day 7 in order to see what will be the reaction of the microalgae. So as you can see, the microalgae response was quite well, indicating that there was a higher biomass accumulation. What about the biomass production? So we use two sources of nitrogen. We use sodium nitrate and ammonium phosphate. And we set up the ratio of 25 parts of nitrogen per 1 part of phosphorus, which was the best treatment. So you can see, using that ratio addition at day 7 resulted in an 11-fold increment of the biomass production, which means for every gram of biomass of the initial about 11 grams at weeks. So, and I also want to highlight that our control unit, however, I would say that the quality of the now about the nutrient efficiency. You see that after 14 days, when optimizing the cultivation conditions, we were able to remove, my body was able to remove between 70 to 90% of the nitrogen in the forms of ammonia, nitrates, and nitrates. And also, my body was able to remove almost 90% of the remaining phosphate from the wastewater. Now, talking about the quality of the biomass, here I'm presenting you the approximate composition of the biomass from the control group, in which we didn't do any optimization process. So you can see we got 40% protein and 45% fiber. You see, you will say that 40% protein is good, right? However, the fiber content, it was really high. So it was really difficult. A lot of fiber in the biomass. So what we did is we fiber content of the biomass. So after the optimization process, we were able to improve the quality, the overall quality of the biomass by increasing the protein by on average 13%, and also the fiber content on average 20%, which is something good because now we need less energy to process this biomass and turn it into something else. So the key parameters, the most important parameters that help us achieve these results were using a nitrogen to phosphorus ratio of 21:5, as I just mentioned before, and also a concentration of 1 milligram of phosphorus per gallon of culture, as well as keeping the pH inside the food bioreactor at 7.5 using carbon dioxide infused. So conclusions from this study show that adequate source improve the metabolic activity. Also, the adjustment of the NP ratio increased. So when we didn't do any adjustment, we saw that after 14 days of cultivation, we were still getting some nutrients in the wastewater. So by adjusting this, the ratio between nitrogen to phosphorus, we were able to uptake most of those nutrients, as I just showed you. Also, another important thing we found is that optimizing the process led us to increase the quality of this biomass, which now we use for downstream processes. And just to mention, we're using that protein to other applications. I'm currently developing a food ingredient using this biomass. As you can see, we're using our waste stream to produce something really valuable. place the foundation of the integration of microbiology into the system. So with this, I conclude my presentation. Thank you very much for your attention.
Your culture of Adi. Which you use, culture of Adi.
Yeah, we started using the pure culture of Adi.
And what was, after some time, was it the same or?
Yeah, that's a great question. So we started using pure culture, chloride virus, in this research study. However, since we're using a waste stream, we're well aware that there is some other, I wouldn't say microbes, but other microorganisms as well that could help the microbiology. We're not sure about what are those microorganisms because that's not the focus of this study. But yeah, I would say that there are some other microorganisms as well in the medium.
No, but are you even saying or there are other algae also? Other algae are also there or?
No, it was the same strain, yeah. Any other question? Yes.
Can you comment on the quality of biomass? The way I was thinking is that the more carbon nitrogen it can uptake, the better quality of biomass. But how does the protein give more context?
The cell itself will choose to produce.
What were those parameters? You change with what? You played with what?
Okay, so the nitrogen to phosphorus ratio. So yeah.
Functional CXO advisor with deep expertise in enterprise CXO advisor with deep expertise in enterprise architecture, AI-driven innovation, and large
Really don't need a mic because there's hardly a handful of people over here.
innovation and large.
Really don't need a mic because there's hardly a handful of people over here. But if you want,
Yeah.
Okay, you can all hear me.
Yes.
Yeah.
Yeah.
Okay, you can all hear me.
Yes.
Yes. I see on top of my answer that you all are grammatical mistakes. I live and breathe IT. So my answer that you all are grammatical mistakes. I live and breathe IT, so I will speak IT. So, as Shamba, let's do something simple where everybody understands and everybody knows what's precision and precision. So the journey that I'm going to talk is looking at Professor Patel and all. Fantastic. We'll talk through this and then touch about it and why everybody should look at it because so by looking at these options what government has given, I want to put a seed of thought in all of you is this is an option that we can go besides the government. Sounds like a plan? Let's move. It takes. How many of you have heard this water everywhere but not a drop to drink, but barely a drop to drink? This is the problem we are in. And who else? We just talk to the bare facts. Used to be the Mother Earth was so lush greenery, but as we fast forward 2025, you see multiple times is it 0.5 or 5%? How is it that Mother Earth is so blue in nature and people who have gone from space stations and all, it's so blue? Why is it that the water consumable? That cracked the hell out of me. So I started thinking, and what I've been saying is, as of now, these around 1.8 billion people of planet. How much? What's the approximate size of the population of planet? 8.5 to 9 billion. So it is 10% of it is struggling for water. Accelerated by global crisis, and who is the number one culprit about technology? I think somebody talked about AI and power consumption. I think the major stakeholder. But we have AI to fix it also. So AI for AI. You have a pill and a disease. I know you're all very well educated, very well knowledgeable, but people like me. How do we educate people and bring awareness everything in the bag. So the last thing is, this is an alarming thing is, around 80% of the water is microplastics. In fact, it's so bizarre that new fetus, the new babies that are being born, there's microplastics in the womb. Just something fathomable, but it's a sad deplorable state. So, and why wastewater management isn't moving at the scale of what AI is being classified into three things. One is an operational. The operations, these are systems, all these SCADA systems, 1950s, 70s, example. I think the major or mayor said that the same example as what we are seeing is these SCADA systems and all decades ago, and it's not easy to do them. So there is a huge operational expense and a huge downtime. So all those things, regulations, everyday goals. We are talking of sustainable development goals. We talked of 17. In IT, we only focus on scope 2 emissions, but we don't focus on scope 1 and scope 3. So when I speak in US with the legacy systems, it's mind blowing. So when you have these kind of issues, what can you do? But you can't say that Cape Town in South Africa had something called a 0 day. So what I did is to write as a quantitative benefit, which is a direct impact. And for water, there is 43.5 billion direct impact. This is the magnitude that water, they knock out the waste. Remember the metrics of the stat showed that only 10% of it is. There's deep tech. I hope everybody's awake. How many of you know what is deep tech? Or it's too sci-fi? So deep tech means, simple terms, deep technology, as simple as that. But there are three things that I only want to really focus. Oh, I see a lot of hands. On three things: cybersecurity, blockchain, and AI. Why these? Why not these? But for these to come, you need something called data. Every system today, even your SCADA system, so using the data, you can have preventive and reactive this thing. So there are a lot of numbers over here, but long story short, I'm not going to run through. What it's going to do is, you have all these systems. When you integrate these things, there are three things that are going to happen. Morning, Professor Patel, while we were driving, he said, using AI, can you do anomaly detection? I said, yes. But what else can you do, he said, besides anomaly detection? The state of AI is something as, remember, like you have two doors over here. If a wrong guy comes in, the door others, so that people have safe passages. This is the level of technology where we're coming. But the goal of blockchain and cybersecurity AI is you want to have safe and auditable transactions. That is the goal. Every transaction of yours, blockchain, and when you verify that it's good and safe, you want to save the record for a legal purpose. To lawsuit or something, you don't go get into that. So these are the benefits of a triple integration enacted by Congress. Maybe you're all too busy studying. Genius Act. Anybody heard about it? Nobody. So maybe everybody's. We've all been talking blockchain degrees, but the problem with blockchain is it is great on paper, but it was used for what is finally happening is in the position to decentralize this Genius Act has come. What is this act that actually does is, it will. How many of you know the treasury bonds? Come on, you all should be knowing treasury bond, right? Safety. Supposed to be safety. Centralization is to cut off intermediaries. Let's say we have a lot of professors from Indonesia, Thailand, Philippines, and all. Today, they have to take their currency, and before they fly to US, an alternate form of currency is a stable coin. A stable coin, so what happens is, there is no speculation. This is the biggest thing that the government has been enacting and proceeding. This act, the Stable Act, will help you with that. So what it does is the stable coin will be linked to some physical value. So in case if it is liquidated, you can actually liquidate the liquidator, the collateral becomes your primary property. What this brings to you? Three things. I raised my hand and I've burned my hands also. So I can't do anything. I have 1 minute, okay, got it. So long story short, because wastewater management is so capital intensive, the Genius Act actually is providing ways to incentivize your token. You can get money. So the traditional ways of fiat currency raising is good. The currency is okay. And then I have 1 minute, so I have to rush. So this is the best part. But if you see here, what they do to the wastewater management, this is coming straight from the last small part from me, is they are giving an incentive for waste to raise money and get money for the innovation. So long story short, saying there's the traditional ways where you've been in the pollution world, but you have smarter ways with the help of technology. We're fortunate that we recently are advisors on a company called and we have worked with the city of Toluca, which is in Mexico, and their problem is the standard. They have base systems. So we've actually used AI to do all these capabilities. We are in the phase 1 and the press release is coming as we speak. It's a stable token where we don't have to work with the city of Mexico. We can work with the people in precision. I think I'm out of time for questions.
How far the anomaly detection, that if something goes wrong?
Straightforward to you. You're a scientist, you know that.
We did IoT devices as well as enabled by the AI program. It will correct it. The human Indian's job, there we failed. So the system is taking. How precise the sensors adding from.
So what we got from Expo is around 74 to 78%. Because there are a couple of problems. The data by the time we get it is a tough data for us. And second thing is when we look at the data from the legacy system, because it's a quality issue. So we are at 74 to 78%. Precision is 100, it's a relative term. They have never used it. They are now able to regulate the water. So the city of Toluca is where Coke and they have around 1 million residents. The problem is when do we regulate to residents? When do we give it to these plants? Obviously, this kind of times we're going to regulate it. So precision is something, it's an ongoing, there's never 100%, but it's an ongoing thing. But I think you're right. Quality, it's a painful action increase the value.
So thank you for the wonderful presentation and the work. So we all are the research fellows and graduate students and like to give us to base or that work in the wastewater treatment or the resource recovery with the deep tech. Any idea?
Since you're all knowledgeable people, which you are, the technologies in deep tech you got to understand. Because when you overlay with the knowledge that what professor asked me, where we are at, you guide to understand these three technologies. Because then you are much more knowledgeable. Otherwise, the big problem right now, what we have an anomaly, but an anomaly for us doesn't mean the same as you. So it's good that you are, AI should be very natural for you. Having an understanding of cybersecurity is good because when you create a model, so it's correct. You have a problem, so your model is skewed. So a little bit of understanding of cybersecurity is needed. Always people like us to help you out. Thank you.
Thank you. Thanks, Mr. Rameshwar, to introduce a new language in the room. For Dr. Uday Kelkar for his presentation on wastewater sludge, biosolids management, prospective regulations, and reuse to achieve. He holds a bachelor degree in civil engineering and master's and doctor of water sanitation in the United States. Sorry. A lot of technologies like membrane, biotechnology, advanced oxidation is created, like innovative business leadership award, all of license from state of Michigan, and is a board certified environmental engineer from American Academy of Waste Youth Association. Let's welcome Dr. Kelker.
Good afternoon, everybody. Thanks for giving us. Now, USA funding is cut, thanks to Trump, but I think we would have more funding coming from different areas, including World Bank. Working with the same organization funded by Government of India, which is funded, really creating a lot of flourishing. However, we also wanted to look at it, how is legislation, because more solar treatment plants are coming up, newer ones are coming up, regulations are coming up, how these wastewater plants can provide a circular economy using the sludge to benefit. And if you really take a look at it, most of the wastewater is being talked about. Now, there is no regulation which is precisely like US EPA 403 Part A for discharge of sludge. There is no regulation. In order to look at it, what regulation has been bring, how we can use this particular wastewater sludge that is being generated at a particular site, for example, the capital, which generates somewhere around 230 to 250 dry tons per day. And presently it is being just simply discharged in this into a 20% or 18% solids and discharged on the land, which is not hygienic, which is not rivers, and you will have more pollution coming down the pipe. So to get that into the process, what we looked at it, how it's a health hazard, lack of any specific guidelines and regulation, no availability of standard guidelines which to stick up with the US EPA Part 403 because it has a class A and class depending upon how much sludge is disposed off in the process. Then develop appropriate framework for using and then do a feasibility for recycling and reuse. Part of this project was funded by National Mission for Clean Ganga. There are 4 or 5 groups that are being funded this whole entire WWM's prerogative or progress. One is the European Union and the other one is Japanese banks. So there are a lot of funds come into this particular aspect to do various treatment aspects. Or seen, which is the national or hybrid annuity model, it's like a PPP through the process. When we look at it, then we look at 4 different cities, but what I'm going to cover today is only one 250 tons per day, number of plants, such quality, treatment, technology, existing applications, markets, and cost. Recovery, energy recovery, phosphorus, electricity generation using biogas, RCNG, how we can use our co-processing in cement plants, as well as using fuel and carbon resources. Later on, using as a fuel and carbon, and I'll show you how that works effectively for operability and process. So we basically looked at the data, collected about 10 to 15 plants, which Delhi has it right now. The largest plant, which is now functioning, is about 560 legal provisions. We don't have yet, so we need to create one. Assessment of reuse options out there into the process. To give you an example, we selected a couple of, for example, Ritala, which is the 40 mgd. Now these are empirical mgds, so not US mgd, so liter, whereas US is 3.74. So we have Ritala, Ufla, Yamuna, and all this. Each one of them had a different sludge dewatering process is to bring it to a certain level, say will give you roughly about 18 to 19% cake solids. Then centrifuge will give you roughly about 20 to 21%. Sometimes people say they will get each sludge from each and every wastewater plant. The sludge collectively into a centralized unit and then pump it either in a liquid form or use it as a truck transportation with a certain percentage so that we can reduce the wastewater in the UK, where they are using a variety of treatment. Combining them into one location or two locations called sludge center, and then using that sludge center used and create a sludge district with various treatment plants connected. The treatment plants connected, use at the plant. Because understand, not all treatment processes in India presently have the same process stream. Depending upon the regulations when they started, for only BOD SS removal. Some of them have only nitrogen removal along with BOD. Have nitrogen phosphorus and the other regulatory requirements. With the new precedents through National Green Tribunal, this is the local regulatory system that started with a new discharge per day, which is actually going to 10 milligram per liter BOD, 20 milligram, and 100 ppm per 100 ml is your fecal coliform. So it's a very stringent material for the slide and so forth. We did slide analysis, and this is a little bit deep slide in the sense we cannot area has some amount of metal, so we were a little bit careful about which combination to take to slide management. A little bit busier slide, but let me walk you through what we looked at it basically. CPAD, which is thermally assisted anaerobic digestion, and then using that, using either hooker press, which is a pilot hooker press, or maybe using sludge through some of the covered situations so you don't get drained out during the rainy seasons, or we could use, which is THP, thermally hydrolysis process. Camby or anybody else to bring it down, and then look at options what we do power, because now there's a regulation back because of this data that the treatment plants which are allowed in generating this part, then we look at it bio-CNG, classification, pyrolysis, and then finally class A. If somebody really wants to take and so forth, it's like this, take a wood and put it onto the fire and put that wood into the soil. It will slowly burn. It forms a coal. And that's the way to look at it. In slow cooking, I call it slow cooking or slow burning, you can create the sludge in this particular thermal pilot that we built for the city. It gave us very good coal characteristics, somewhere around 2300 to 2500 kilojoules per kg, which was effective enough for the thermal power stations to use that as a substitute to coal. To give you an example, here's the sludge purification, which just basically became like a deep powder, black deep powder. But funny part is, you can't really take this and put it into the furnace of the power station because it will not go in there properly. It has burning characteristics, but it's most hazardous to take it and move it and put it into a furnace. So it has to be made into pellets. So we looked at it, how to do pellets. And the problem was, we couldn't use anything else. We had to use water, a small amount of water, so that reduced the kilocalories per kg from 2500 to 1900 to 2100 range. But that was enough for the thermal power stations. So we shipped almost 150 tons of these palletized sludge mass to them, and they fired it for almost 10 days to see how that effectively works when the coal substitutes are not there, or coal substitutes are needed for the processing. If you look at the cost, and now these are in rupees, but I still converted them in millions. It was in Indian, the original was in crore, which is 10 million is 1 crore. But I converted that most of it into millions. So if you look at it, classification, clarification, thermal drawing, and so forth. And then gave a generalized assessment and looked at a clarification for Delhi, where they can take the 250 tons per day sludge, clarify it, and give it to NTPC, their thermal production, and solution for Clean Ganga as their PE or project engineer for almost 5 or 6 projects out of the 10 that are presently being run. What we did basically is to look at what is called as ULB, that is urban local body, which is the smaller cities or the larger cities. How do they take the amount of money, how do they take the amount of sludge, what they need to do, what is the nearby solutions that they can apply, and how they can go directly into a Class A or Class B, and that finally dictated what type of material they need to use. If they're going for soil amendment, biofertilizer or land, they need to go to a Class A sludge regulatory requirement as per US EPA, and then so forth and so on. What really helped us is to understand when we looked at it as a thermal assessment for thermals, instead of coal, giving it as a pelletized, then the thermal power stations were happy to look at it because they were able to save almost 10% of their daily coal mass if they can get 240, 250 tons per day in the production process. They would be saving almost 100,000 rupees or $100,000 per month, so almost 1.2 or 1.3 million per year in the process. So this was looking at it, a bigger city can take the sludge mass and put it back into the thermal, that's number one. Or, even if they can take that, though it looks at blanks, there's a lot of research done through agriculture, worldwide data shows that this can be used as a carbon source, because there's a lot of agriculture area in India which is now carbon deficient. They have enough nitrogen, they have enough phosphorus, supplement to reduce the carbon deficiency. Then we looked at it, which is similar. Petitioner who's got the money to bring in, and there's a bank guarantee into the fund in India presently, is because probably the central government is giving the guarantee for those concessioners that yes, how to get a concessioner agreement going towards the NTPC. Because now NTPC, I think with that, I take your time. Thank you very much. Really appreciate it. Because everywhere qualification was not essentially correct, so we had to do agricultural use also for near Bangalore, where there's a lot of agriculture nearby, or there are some of the cities. Data analysis will be good for you. So this is just 1 year worth of entire data that we have created and looked at it very quickly. Thank you.
Ash content compared to biomass. So did NTPC look at like
Two types of coal. Grade A coal and grade B coal.
okay.
This was very close to grade B.
Okay.
Many times, others don't get consistently coal A of quality grade A. And also, if they use this along with that. So the combination was much more effective rather than just simply as a straight. That's number one. Number two, they also needed to modify. They have not done it yet, but we did some testing with them to see their furnaces need to be slightly modified to get a combination. Yeah. So, but ash was not an issue because it was comparable to coal B and so forth.
And another follow-up question.
Sure.
In terms of the carbon, when you are performing anaerobic digestion, you are converting carbon to methane, biogas. So keeping the carbon, avoiding anaerobic digestion could be like a better value proposition, save cost. So did you guys look at that?
We looked at combinations, and in Indian scenarios, the volatile VOCs are not as high as you see in Western countries. Typical VOCs are typically 35 to 40%. So the city can either choose, if they don't have digesters now and they don't want to build it, they can use the straight and save it on the carbon. So that was
For dry turn, energy consumption for what is this?
I don't have the numbers off my head, but just to give you a number-wise, don't take me on the number exactly, but if you look at it, say 10 rupees, then the rest of them were almost 18 rupees or 16 rupees. Because the tariffication cost, the heat that is coming up, or at least for this particular project, we use the heat coming from. If you don't have the heat, or you don't have the digestion, obviously that cost will go up, almost 25 per ton or dollar per ton. Thank you. Thank you for your time. Really appreciate it.
The last presenter for this session is Mr. Karthik Manjula. He will be talking on navigating global nutrients at Civil and Environmental Engineering Department at Virginia Tech. His work is focused on the mathematical 13 years of process engineering experience in anaerobic digestion and nutrient removal process.
To cut it down to a point where like there are several good presentations, I am kind of trying to capitulate on that and then let you guys leave early. So three main objectives I want to discuss today is from a nutrient removal standpoint, regulations has been one of the main drivers across the globe, and the technologies have been in and out, and some survived, and they have been technologies which have been more than 4 or 5 decades. So we are going to touch on a few of them. And what are you thinking when you are looking at the circular economy? How you are recovering nutrients and also recovering energy, important elements. So I'm going to paint a broad brush picture today. Sometimes there's a significant amount of chemical, energy, and a lot of O&M goes into that. So if you look at some of these 5 items, most of the items are total nitrogen. One category is less than 10 milligram per liter, but there are some places where the total nitrogen is as high as 30 milligram per liter, and phosphorus goes the same way. It can actually go higher or lower. So the key element is one technology, one limit, which applies at one plant may not be applicable for other facilities. So you need to be cognizant of that aspect. So how do you go about unpacking this problem? You need to look at from a mass balance standpoint, what is in your wastewater? Because a lot of times the carbon, which is the COD, is one of the key elements you are trying to understand, and how much of that is readily biodegradable. And in tropical climates where the atmospheric temperature, the ambient temperature is higher, the activity is also higher, so the basin sizes are quite small. So by the time wastewater reaches the treatment plant, a lot of the unbiodegradable or slowly biodegradable material gets to soluble biodegradable. And that VOC content is less because a lot of that is being already driven, the readily biodegradable stuff is. When you look at the treatment scheme, how much of that you are actually treating and how much of that is actually helping is of importance. And specifically when you are looking at the nitrogen and phosphorus components, when you are going to really low effluent limits, how much of that is dissolved or recalcitrant organic nitrogen? Those are the few aspects which will dictate the technology in terms of how much the technology costs and how sophisticated it is. So just to give a flavor for this, for the ammonia to TKN ratios and the phosphorus to COD ratios, really high soluble ammonia, and those require a lot of energy and the technologies required. Specific examples where the amount of attention is lesser. So if you look at so that's a really large retention time when the flows are complexity in the process. Likewise, trickling filter is another example. I think one of the previous speakers talked about trickling filter benefits through attachment processes. And sequencing batch is another process basically where you are trying to have within one basin you are trying to get most of the action done. So the intent of this slide is to give a flavor for there is nutrient removal efficiencies on the technologies. They have their merits and demerits, but the key takeaway point I want to emphasize is what is the how much mass you need to be removing, and what are some of the key elements in terms of the regulation standpoint is what the technology should dictate. And a lot of times the operations intention, how many operators are required for a treatment plant, that gets lost. But it is more important for the engineers and also the utilities to keep in mind that if you are able to reduce the complexity of the treatment process, that goes a really long way. And the scale of troubles and everything, which the previous speaker has mentioned. So if you are trying to dummy it down, it will go really, really long way. So understanding and taking a step forward is using a unified modeling method to actually calibrate the existing performance and then see how we can actually do more within the treatment plan. And for that, you require some special sampling in terms of understanding what is the soluble and particulate fractions, which I have mentioned previously. And then using modeling as a tool to actually predict and be prepared for the upcoming upgrades and things of that nature. So one thing which I cannot emphasize enough is we should not stop innovating. We know things get to a status quo and we are continuously set it and forget. But is there anything we can do? Can we cut down the O&M cost? Can we cut down the chemical cost? Or is there anything can we accept other high-strength waste and then make revenue out of it? So we need to be thinking of wastewater treatment plants more from a revenue generation standpoint rather than just treating and forget standpoint. So this is a pretty picture of what are some of the possibilities you can do at a wastewater reclamation facility, basically. So you can capture carbon in the primary treatment, and then within the secondary treatment, you can reduce the amount of air you are putting into the. And by virtue of anaerobic digestion, you can actually generate more biogas and then use that for a beneficial use. And also on the solid side, some of very interesting stuff is happening, which is PFAS has been out there, microplastics are out there. So land application is going to be a challenge. So how can we innovatively convert the biosolids towards biochar? And those innovations are going to be more prevalent across the world in coming future. So just to give a takeaway point, on primary treatment, the main advantage is you are able to remove the solids and BOD, right, with the minimum energy input, and then you are also able to remove phosphorus by virtue of it, which is a limiting agent. And energy is another element where there are, in US, there is a disparity in terms of where energy costs are, Midwest versus East Coast versus West. But in general, trying to go low on the energy and low on chemicals should be the norm. And some other elements, especially the synergy between wastewater treatment facilities and industrial treatment facilities, could be how can we actually accept some of these really good high-strength waste streams and then get energy out of that and then make it a more synergic effort. And going maybe further like ways beyond, we can think of opportunities for nutrient recovery from wastewater treatment plants. So in every flow scheme, like there is an opportunity for you to recover the soluble ammonia and the or the phosphorus from your streams by virtue of like soil enhancement conditioner or even the pellets, which can be used as a fertilizer. And there are a lot of innovations happening in this one to actually increase the quality of the products coming out of the system, and a lot of competition in terms of like different vendors who are providing it. But when you're looking at this, like as a utility, one of the key elements you need to be thinking of is like how many dry tons of that product will I be generating, so that it makes more sense when I go look at from a revenue generation standpoint. And the last slide I want to take home is the emissions. The impact of emissions is another element which a lot of times we don't take into consideration until it's like it is really a big problem. But in terms of what are some of the greenhouse gas emissions and how does they impact is what this takeaway slide is. I don't want to go in detail, but with that I would actually try to close this and maybe have more time for more questions.
Yeah, so one of the statements, so you noted like North America, Europe, when we're talking about less than or equal to 1 milligram per liter, it's what we're looking for in affluent or in the ambient condition. And working in that field, it's really, we're looking for beneath 0.1 in the ambient.
The less than one was
a catch-all, yeah.
it was to create a perspective in terms of like there is disparity in the phosphorus, which is somewhat called as a limiting agent. And when you go less than 0.2 milligrams total phosphorus, you need 2 series of filtration mechanisms, and then your flow scheme gets really complicated.
Yes, indeed.
Try to use that 0.3 total phosphorus flow, and then try to supplement with some other things when you're looking at the limits.
Got it.
All right.
Special thanks to all the speakers for presenting their wonderful work and giving the insight into their work. See you tomorrow at 9. Thank you very much. It's 9. 9 is first seven. The first seven will be from 9 to 10 a.m. Thank you very much.
Oh, see
But she's just checking if she can see the notes. Okay.